Okay, we're going to look at how to find a Cartesian equation from a parametric equation. So just a quick reminder, a Cartesian equation is where we define the function in terms of x's and y's, usually in the form y equals some function of x. So that's what we're aiming for here. There's no single method to do these. You usually have to look at the functions you have and think, well, which one do I need to work on a bit first? In this case here, x equals sine t seems simple enough. There doesn't seem much I can do with that. Y equals cosec 2t. That's a bit more of a complicated function. It's probably worth having a look at this first to see if I can tidy it up in some way. Make it look a little bit more like sine t. So I remember that cosec is 1 over sine. And then I realised that I have different angles here. This has an angle of 2t, this has an angle of just t. So I know that I need to use the double angle formula on this. Double angle for sine 2t, we should remember, is sine t cos t, 2 sine t cos t. Okay, so I've got that. That's good, because I've got a sine t, and I know that sine t is x. So I can just replace that sine t with an x. However, I now have this cos t. I know I want to write it in terms of x, but x is defined in terms of sine. Whenever you run into a problem like that, we know that we're going to use the identity. Using that identity, we can rearrange it and see that cos t is equal to 1 minus x squared. Therefore, we have our function, y, written in terms of x. You'll need to look for double angle formulae and the use of identities. Identities are usually used to either transform sines into coses, tan into sec. Let's put t's in there. Or finally, cosec into cot and vice versa. Okay. They're the main tools you'll be using for these kinds of questions. A final thing that they may ask you to do, they may ask you for the domain or range of the Cartesian equation. To find the domain, we need to look back at our original function. It's no use just looking at this and thinking what set of x values would be acceptable. X was previously defined in terms of t. So we need to look at the x value and think what set of x values can I get given the set of t values I'm allowed to put in. So looking at this, I can see that my x, as t starts at 0, I know that sine t is 0 at that point. And then t goes all the way up to just about pi over 4. It cannot be pi over 4, but it can get as close as we want to it. So maybe you sketch a sine graph just to remind you of its shape. We see from there that when t is 0, x is 0, and notice that as it can equal 0, x can equal 0 as well. But then we can never quite reach pi over 4. Sine of pi over 4 is root 2 over 2. So we have a strict inequality there, as we can never quite have that value of t. Similarly, we can now look at this and think, well, what set of y values can I get out of this? You could now use your x values and plug it into there to find your range. However, you may have made a mistake in there, so it's probably better to go back to this definition and work from here again. And we're told that y is equal to cosec 2t. I should probably fix this question because I've just realised that cosec is not defined at 0. Thinking of the sketch of that graph, it looks like this. So that was a bad definition. I'll just fix that. And then we can see that cosec goes all the way up to infinity, So y has no upper limit, there's an asymptote there. However, its lower limit at pi over 2 will just be 1. So I know that y is strictly greater than 1, remembering I cannot ever actually put in pi over 4, and there is no upper limit, so I don't need to restrict it on that side. That's how I can find the Cartesian equation from a parametric equation. Put everything, try and write this or your most complicated function so it looks more like the other function. In this case I've written the cosec 2t as 1 over sine 2t. Maybe you'll have to use some double angle formulae or the identities to try and write everything in terms of your x, as I've done here. And then if they ask you for domain or range, we don't really look at this function. Remember, we may have made mistakes there. We go back to this function up here and we say, well, what values of x can I get out given these values of t? That's your domain. What values of y can I get out given these values of t? That will give you your range. Okay, so everything works from these original definitions, and it's good practice for your trigonometry as well.